Okay, good morning everybody. We're going to get started here with warming up with a couple problems, getting us prepped for section 7.2. So what I'd like you guys to do, and I'd like to ask the sub to give them about 5 minutes and work on these 4 problems. And all I'm asking you guys to do here is solve for y. So with a scrap sheet of paper, go ahead and try and solve all these problems for y. Or if you wanted to pull that whiteboard out from underneath you and use that, go right ahead. So about 5 minutes, go ahead and work on that. So just go ahead and pause the video, and then at the end of the couple minutes here we'll go over the solutions. Okay, so let's take a look at that one in the top right. This is us going ahead and getting this y by itself. Pretty straightforward, right? 2 steps here. The first thing you're going to need to do is add 7 to both sides, giving us x plus 7 equals 3y. And then our next move here is to get the y by itself. Now we need to divide that by 3. And then over here, make sure we're being very, very careful how we go from here. Since it's already x plus 7 there, we have to divide the entire thing by 3. So there we have our solution solved for y. We have it as x plus 7 divided by 3. Let's look at the bottom left. Now the trick is with this one is we have to have a clear understanding of what our order is here if we were to evaluate from y. Notice the first thing we'd have to do is add 5, and then the second thing we would do is divide by 8. So to undo it, remember, kind of just picture visible parentheses there, we have to multiply both sides by 8 first to cancel that out, and then we'll multiply this by 8. And so then once we have that 8x over here, now we can subtract the 5 from both sides, which gives us our answer here of 8x minus 5. If we go to the upper right one, kind of a funny thing happens here. The first thing we have to do there actually is subtract 4 from both sides. And so then what we end up getting here is x minus 4 being equal to a negative y. That minus y up there kind of gets turned into a negative value for that y. And so we aren't interested in what negative y is, we're interested in what positive y is. And so you can either make this an algebra by dividing everything by negative 1, or just realize if we want to make negative y a positive y by making it the opposite, what we do to the one side, we have to do the other, so we'll make everything else on the other side the opposite. And there you have it. We have negative x plus 4 being equal to a positive y. So looking at the last one down there, obviously our move there's got to be taking the square root. And when we take the square root on both sides, notice what happens to the x there is you actually don't forget about your plus minus. So there we go. Here's our answer there, y being equal to plus minus square root of x. So there, take a look at this one. Let's do a couple more things here. I'll give you about another minute to look at this. And I'll just keep rolling here while we do it. What would happen if you had to figure out what f of 2 is here? Or g of 14 of both of these functions? Realize we're substituting 2 in there, so now we have 3 times 2 plus 8. So that would give us, 6 plus 8, so 14. And notice if we do the same thing over here, putting in a 14 there, 14 minus 8, which would give us 6. 6 divided by 3 gives us 2. Interesting. Let's make a mental note for that later. So Act 1 here. What we did yesterday is we evaluated exponential expressions. We looked at growth and decay. Now let's take a look at inverses of functions. So if we're being asked to find an inverse of a function, a very simple way of getting an inverse of a function if we're looking at a graph of it is we're going to reflect it across this line y equals x. So if we have a graph here, the line y equals x just means anything that x is, y is going to be the same number. So you're going to end up with a line that looks like this. Notice we have 1, 1, 2, 2, 3, 3, 4, 4. And so there's our line y equals x. And so getting back to this inverse concept here, what that means is if you take any point here, say at 4, 6, and you reflect over at line y equals x, notice what happens here. Notice we move this point here. Remember, we got to stay perpendicular to the reflection line to do it properly. We end up right there. And what's the coordinates there? Yeah, it's 6, 4. So notice what kind of happens here is that the x and the y values actually just switch their locations. Pretty convenient here. So let's put this in action with the problem. Suppose we weren't just looking at one point, but what if we were looking at several points here? Notice the directions on the problem is asking us to graph the inverse after we first graph the relation. So let's graph this relation first, which looks something like that. Notice they want us to connect the points. Very rarely are you going to be asked to do that, but let's connect it because I think it's tied to the domain and range here. So if they're asking us to write the domain and range here, remember the domain is just asking us to write in all of the x values that are in play with this given function. One way of looking at it is if we were to carry all this information down and look at this in terms of a number line, notice that we have a nice little compound inequality that we can get out of this. Our lower bound is 0. We have all the numbers going from 0 all the way to, I think that's 8 there, right? So we can write our domain just like that. Now our range, we do the same thing. Notice our range of values here, if we're looking at the y values, only range from 2 to 7. Now, when it comes time to graphing the inverse, what we're going to do is we're going to take those values, all those points right there, and all we're going to do is just reflect them over that line y equals x, just like we did earlier. So what we're going to do is we're going to take all of those points right there you see in blue, and we're just going to switch their x and y pairs. Notice that's just the relationship here. And so we'll graph out those points. Let's connect them just like we did with the blue graph. And we end up getting a relation that looks something like this. Now what about the domain and range? What do you notice about, or what do you predict is going to happen with the domain and range here? Yeah, that domain and range is just going to switch their spots. When we look at both there, notice the domain and range switches just like x and y switches. Kind of makes sense, right? So let's put this in action. We're going to close this little segment of the lesson here, and what I'd like you guys to do is I'd like you to take a look at this function. I'd like you to graph the inverse of that function. And then with the next video we'll go over the solution.